This is the lesson for Chapter 7, Section 3, More Multiplication Properties of Exponents, day number 2. So first type of problem that we're going to see is one that talks about scientific notation, raising a number in scientific notation to a power. So let's take a look at our first problem. So the rule we learned yesterday is that we're multiplying the exponents when we end up having that exponent on the outside of a set of parentheses. The important thing to remember is that if you don't see an exponent on a number, it's always 1, and so that allows us to multiply that exponent by the exponent of this number. So it's 1 times 2 times by 10 to the 5th times by 2. So I end up getting 4 squared times by 10 to the 10th power, and when I multiply 4 squared, I get 16 times 10 to the 10th. So the thing to remember is, especially if this number is a number larger than 1, you're going to end up typically seeing a value in which we need to reduce this, because remember, scientific notation is in this form, a times 10 to the b power, but a needs to be between greater than or equal to 1. So let me fix that real quick. So it needs to be greater than or equal to 1, the absolute value of a, but less than 10. So when I go ahead and move this decimal back 1 space, that means I made this one smaller by dividing it by 10. It means I need to add 1 extra exponent here to make that so it's multiplied by 10. So it's 1.6 times by 10 to the 11th power. So moving on to the next one, I do the same sort of thing. I bring every number to that power. And so I'm multiplying the exponents. And so I have 2 to the 5th times 10 to the negative 15th. So 2 to the 5th ends up being 32. And then I bring down the times 10 to the negative 15th, and I need to make this smaller again. So that means I need to add 1 extra 10 here being multiplied, since I divided this side here by 10. So it ends up becoming 3.2 times 10 to the negative 14th power. And looking at this problem, it says the expression 1/2 mv squared gives kinetic energy in joules of an object with a mass m traveling at speed v meters per second. So it asks for what that kinetic energy is for a mass of 2.5 times 10 to the 5th kilograms traveling at a speed of 3 times 10 to the 2nd meters per second. So go ahead and substitute. So we've got 1/2 times by m, which is 2.5 times 10 to the 5th, and then v squared. Well, v is 3 times 10 to the 2nd, so we're going to take that expression and square it. So I bring down the 1/2, still have this 2.5 times 10 to the 5th power, but then over here, when I square each of the components inside the parentheses, I end up with a 3 squared times 10 to the 4th power. So I can start moving some terms around. Everything's being multiplied here. So I have 1/2, I've got a 2.5, and I've also got a 3 squared, which ends up being 9. And then over here I'm adding up the exponents, so times by 10 to the 5 plus 4 power. So I start taking a half of 2.5 and then multiplying by 9. Let's do that real quick. We've got 0.5, which is the 1/2, times by 2.5 times by 9 gives us 11.25 times 10 to the 9th power. So again, we need to make this smaller by 1, so we're dividing this side by 1, or by 10, and that means I need to multiply this side by 10 to keep it in balance. So it becomes 1.125 times 10 to the 10th power. So again, that's 10 to the 1st, and so I'm adding up those exponents. So let's take a look at another set of problems. Here we're supposed to complete the equation. So remember, the rule is multiplying the exponents, right? So we've got the answer here, we just don't know what this number is. So I'm going to call this x. I'm going to say the box there is x. And I'm going to solve for x by doing some opposite operations. So typically I'd multiply 1/3 by this value, and it would equal negative 12. So to find out what that value is, means I need to do an opposite operation. I need to multiply by the reciprocal. So x must be negative 36. So to make that true, we'd have m to the negative 36th all to the 1/3 power equals m to the negative 12. So the same sort of thing here. We're multiplying this value. I'll call this x again. Negative 4 times by x equals 1/2. So to get that, I'm dividing by negative 4. So dividing by negative 4 is the same thing as multiplying by the reciprocal, negative 1/4. So x is negative 1/8. And you can check to see if it works. 4 times 1/8 does give us 1/2. So the negative signs will cancel. So y to the negative 4th all to the negative 1/8 power will equal y to the 1/2 power. So looking at the next one, I'll box what the answers would end up being. So again, I'm calling this one x here, and maybe since I've got x's in the problem, I'll change that up a little bit and call it something else this time. Let's call it an a this time. So a equals the box. And so I'll go ahead and look at this part here. I need to get y. See, there's no y here. So I need to be able to cancel that y out. So I'm thinking of what times by 3 makes 0 is what I end up needing to get. So if I divide by 3, 3 goes into 0 times. So a must be 0. So it must be this, 3x to the third, y to the 0 power, all to the third power, equals 27x to the 9th power. So you can see how the 3 times the 0 makes 0. Any number to the 0 power is 1. Well, last types of problems here we have to simplify. So I'm going to use that distributive, or multiply the exponents, use that power of a power rule, and b to the 1/6 times by 3, and then times by the b to the 1/6. So I have b to the 3/6. I don't reduce that fraction yet because we still need to combine it with the b to the 1/6. So the rule is you add the exponents. 3/6 plus 1/6 makes b to the 4/6. Now we'll go ahead and reduce that fraction. b to the 2/3 power is that answer. Now this next one, we distribute that exponent over all the numbers inside the parentheses. So we have 2 squared x to the negative 6th, and then over here same thing. Distribute that 2 over both these terms. So it's 0.2 to the 2nd power, x to the 2nd power. So we'll square 0.2, and I'll go ahead and multiply out the 2 squared. So I end up with 4, and then here I have times by 0.04. So 0.2 times 0.2 is 0.04. And then I count up the exponents. So negative 6 plus 2. So I can go ahead and multiply these two numbers. Makes 16, but that moves the decimal 2 spaces over. So 0.16 x to the negative 4th power. Now looking at the next problem here, 3 is to the 7th power, but and it's all raised to the 2nd. So it makes 3, and 7 times by 2. Same thing here. I have 3 to the negative 4 times by 3. So this makes 3 to the 14th times 3 to the negative 14th. So when I add up those exponents, I end up getting 0. So anything to the 0 power is just 1. So on this next problem we have 4x y to the 2nd. Notice how that's not in parentheses, so nothing to distribute there over those exponents. Any 0 to the 4th power, that's just 0. That's 0. And then I have the y, negative y, to the negative 3rd power. And so notice how everything's being multiplied here. I can go ahead and combine some of these terms. Now, let's think about this as a negative 1. I'm going to change that just a little bit in case you see something like that. So on this one, let me erase this part here and we'll redo this section. So I'm going to think of this as like a negative 1. And so I'm going to go ahead and distribute that. And so I have negative 1 is to the negative 3rd power times by y to the negative 3rd. So notice how everything's still being multiplied though. And so I could combine some y's here. I can combine these two terms once I take those exponents, but we still have this term right here, this 0. Any number times 0 is going to be 0, so 0 in this case is going to end up being the answer. Those are the types of problems you're going to see on tonight's homework. Good luck.